All right, this video is on getting common denominators. So we've already looked at how to add and subtract rational expressions after you have a common denominator. But a lot of times in problems you don't have a common denominator, and that would be the first step, would be getting a common denominator so that you could add or subtract. So first, we're going to look at how to get a common denominator when each expression has a denominator that is a monomial, and then we'll look at what to do if you have a combination of a monomial with a binomial or a trinomial, or maybe both of the denominators would be binomials or trinomials. So here's the first example. We have x plus 1 over 21y minus y minus 3 over 7y squared. So what's going to be helpful is to kind of break that denominator into pieces. So to look at the numbers first, the coefficient first, and then look at the variables. You might have more than one variable, you might just have one. So here we just have the variable y. So between the 21 and the 7, we want to look to see if there's something in common, kind of like the idea of a GCF. So between the 21 and the 7, I can see that they have a 7 in common. So between the 21 and the 7, this one's got the 7. This one actually is 7 times 3. So they've got something in common, but this one has a little bit more. Between y and y squared, they also have something in common. They both have y, but this one has a little bit more. It's got a y squared. So this one is times y, this one is times a y squared, y times y. All right, so when I build that common denominator, I want to make sure that I have all of these pieces involved. So I need the 7 because they both have that. Then this one has the 3, so I'm also going to need that. And then they both have a y, but this one has a y squared, and I need to make sure I take everything into account. So I'm going to need two y's. I need a y squared, right? Now I'm writing this out, and I'm writing this out deliberately, because when I write each of these pieces, then I can kind of compare it with this common denominator, and I can know exactly what each piece needs. So my common denominator is 7 times 3, that's 21y squared. So the first fraction has 7, has the 3, has the y. 7, 3, y. It doesn't have the next y, so that's what it's going to need to have the common denominator. The next one has the 7 and the yy. The 7 and the yy, it does not have the 3. That's what it's going to need to have that common denominator. So now I can go through and I can take my fraction and I can multiply by that thing that it needed on the top and the bottom. So I'm going to multiply by y on the top, multiply by y on the bottom. Multiply by 3 on the top, multiply by 3 on the bottom. So for the first day that we practice, I'm not going to have us do the entire problem from start to finish. I'm just going to have us do this process of figuring out what the common denominator is, multiplying each fraction by what it needs, and then writing the problem. And then we're going to be done. So this is exactly what we're going to do. So we know that the problem needs a y in there. We went ahead and multiplied by y. I get xy plus y on the top. I can see that when I multiply by y on the bottom, I get 21y squared. And then I distribute the 3y minus 9. And then I get 21y squared. I can say I've got that common denominator. I'm going to leave it there. At this point, you should recognize like, oh, that kind of looks like the worksheets we were doing. That's like the start of the problem on the worksheets. That's why we're leaving it there, because at this point, you guys know what you would have been doing from there. All right. On our second day of practice, we'll do the entire problem from start to finish. But for today, we're just making sure that we can do just this one piece of making sure that we know how to get a common denominator. I don't want to do too much all at once. All right. So comparing the 6 and the 24, we want to kind of look at what the GCF between those are. So between the 6 and the 24, they have a 6 in common. So this would be the 6. 24 would be 6 times 4. Between the u and the u squared, this one needs a u. This one is going to need a u times u. So the common denominator is 6 times 4. And then we need the u squared, u times u. So 24u squared. So the first fraction has the 6, has the u and the u. It's going to need the 4. The second fraction has the 6, the 4, and 1 u. It's going to need the second u. Okay, so I've got v plus 5 over 6u squared, and I need the 4. And I've got u, not plus, minus, u minus 2 over 24u, and I'm multiplying that by u on the top and the bottom. And then I'll go ahead and distribute. I've got 4v plus 20 over 24u squared. U squared minus 2u over 24u squared, and I'm set. Two x minus 1 over 18x plus y plus 4 over 48y. All right, so this one, the numbers are a little bit more difficult. Between 18 and 48, we have to think about the numbers that are in common there. Both of those are divisible by 6. So I know that they're both going to have a 6 in them. 18 is 6 times 3. 48 is 6 times 8. Okay, and then 18 has the x. 48, that's got the y. Okay, so our common denominator needs the 6 because they both have a 6. And then it's going to need a 3 and an 8. One of them's got a 3, the other one's got an 8. And then we're going to need an x and a y. One of them's got an x, the other one's got a y. Okay, so when I multiply those on a calculator, I get 144xy. Okay, so now I look at what they need. This one has a 6, a 3, and an x, so it's going to need an 8 and a y. This one has a 6, an 8, and a y. It's going to need a 3 and an x. So it's pretty clear each time we work with it. Since we've broken down the denominator that way, it's pretty clear to be able to see exactly what is needed. 8y on the top, 8y on the bottom. Three x on the top, 3x on the bottom. Okay, so we can go ahead and distribute 8y times 2x, that's 16xy. 3xy plus 12x. Okay, so that is it for the monomials. Okay, for the next we have monomials, binomials, and trinomials, so everything. So you'll notice it's a little bit similar, but it's also kind of, a little bit different. So here is the example, the first example for this one. We're going to have 5 over 3, so this denominator is a monomial. And then we have 3x minus 6 over 6x plus 3. So the second denominator is a binomial. So when we look at these, when we look at those denominators, we have to do our typical factoring. So before I even start to think about what makes up that denominator, I have to take the GCF out. Between 6 and 3, there's a GCF of 3. So divide out the 3 and I get 2x plus 1. So I'm not even going to look at this denominator anymore. I'm going to compare these. Okay, so this denominator, that one just had 3. Okay, that's easy. This one had a 3. Oh, and it had a 2x plus 1. Okay, so I've got two different pieces to consider really. So my common denominator, now I'm going to basically build it the same way I did with those monomials. We just have one that's, it's a plain number, and then the other one, I'm going to think of the parentheses kind of as a whole unit. Kind of like when we were simplifying, we thought of those with a parenthesis. It was like a whole unit. It was a chunk of something. So this is a whole chunk. So the 3's are in common, and then we've got a chunk of parentheses that has to be like a whole group. So our common denominator needs a 3, and it needs a 2x plus 1. All right, so when we look at the denominators of what we have, this denominator has everything that shows up in our common denominator. It's got the 3, it's got the 2x plus 1. This one, however, it's got the 3, it does not have the 2x plus 1. Okay, I'm going to go ahead and write down what I've got. I've got the 5 over 3, and I am missing the 2x plus 1. I'm going to go ahead and put that. 2x plus 1, 2x plus 1. Okay, my other fraction is actually missing nothing, so I don't even have to write. I'm just going to copy it down. And so I can go ahead and do my distributing. I've got 5 times 2x is 10x plus 5. And I like to leave my denominators in factored form. And so I'm going to go ahead and do that. And I'm done. So it feels a little bit different than the monomials did, but the process is essentially the same. It just feels a little bit more confusing. Okay, some of you might be watching how long this video is. I apologize in advance. That was unfortunate, but it will be a little bit longer than the other ones. Okay, 2 more examples, we can get through it. Here's the next one. We got 6n over n squared minus 16 plus 3 over n plus 4. So we have 2 binomials this time. This one cannot be factored. It kind of looks like a factor the way it is, so I'm going to go ahead and write it like that, n plus 4. This one is difference of squares, so that one can be factored. If you guys recall, difference of squares is 2 sets of parentheses, one with a plus, one with a minus. So we got an n plus 4 and an n minus 4. So if we're thinking of the parentheses kind of as chunks, so if we were going back to our monomials, we're kind of thinking as like this is one thing, this is another thing, this is another thing. So here I've got like one thing, another thing, if that makes sense. So when I look at my common denominator, I can see that one thing that needs to show up in the common denominator is n plus 4. They both had that, so the common denominator, needs it. And then the other thing, the other factor that needs to show up is n minus 4. Right? So that first expression has both of the pieces that show up in the common denominator. The second one doesn't have both of them. It needs the n minus 4. All right, so I'm going to go ahead and copy this down. I've got 6n. I'm going to use the factored form of that common denominator. Going to go ahead and put my n minus 4, n minus 4. Be down what I have. So 3n minus 12, n plus 4, n minus 4, and I'm done for that problem. All right, last one. 2m over m squared plus 5m plus 4, so we have a trinomial this time. 6 over m plus 1. That's a binomial. So this one I'm just going to say m plus 1 in parentheses, that's a group. So we got one factor right here. Over here, I'm going to see what the factors are that I'm talking about. We're multiplying to 4, adding to 5. The two numbers that do that are 4 and 1. M plus 4, M plus 1. So when I see what would build my common denominator, I'm going to need M plus 1 because both expressions have that same factor in the denominator. They both have M plus 1. But this expression has M plus 4 in the denominator, so I'm also going to need that. So for the denominators to be the same, this one is going to need the M plus 4. This one doesn't need anything. It can just be copied down. So I have 2m over m plus 4, m plus 1, minus 6 over m plus 1, and that needs to be multiplied by m plus 4. Then I can go ahead and distribute negative 6m, not negative, sorry, I was thinking of the negative from the negative problem. We're not messing with that right now. 6m plus 24 over m plus 1, m plus 4. And we put that underneath, and we are done.